we'll be hosting on this topic. As some of you might know, in May of 2013, the Department of Environmental Conservation's Watershed Management Division, through the Ecosystem Restoration Program, released the Vermont Stormwater Master Planning Guidelines, which some of you probably have seen. The guidelines establish a consistent, structured, and workable approach for identifying and prioritizing community-specific stormwater management opportunities in both rural and urban environments. Today's webinar is going to elaborate on the purpose and need for stormwater master planning, as well as what's involved in the process. So it's essentially going to be a general overview. Future webinars will go into more detail about the various approaches to stormwater master planning. Today we're thrilled to be joined by Andres Chorizo of Watershed Consulting Associates. Watershed Consulting Associates is a Vermont-based firm specializing in stormwater management consulting services, and Mr. Chorizo is the principal hydrologist and co-owner. For the past decade, Mr. Chorizo has worked with municipalities, federal and state agencies, for fitting existing problems and better planning for new development. His work has covered New England, New York, Rocky Mountain region, a number of different places. Mr. Chorizo holds an undergraduate degree in geological sciences from Tufts University and a master's degree in geography with a hydrology focus from the University of Colorado at Boulder. Just a few things before I pass it off to Andres. We are recording this webinar, so we're going to have a link to that posted on our YouTube channel, and I'll share that link with all y'all later. Attendees for the webinar are going to be muted throughout the session. If you have any questions along the way, feel free to use the chat or question box. We're going to hold all questions until the presentation is done, and then I will just ask those questions to Andres when the webinar is done. We'll try to get through as many of them as we can within the hour-and-a-half time frame that we've got. I also just want to make a note that we're going to be using Prezi as the format for today.
Good afternoon, everybody. Thanks very much for joining us here. This is going to be the first in a 5-part series dealing with stormwater master planning. Very important topic. I should also mention I'm here with Dana Allen, an associate of mine, who did a lot of legwork to put this series together. And Dana's here, and he'll be helping field questions as well at the end if there's time. But I just want to dive right in. This first webcast is really intended to be a primer and basically to get everybody on the same page. And there's some people listening, I'm sure, that have quite a bit of knowledge in stormwater and possibly master planning work as well. And then maybe there's others that stormwater is a new introduction. So we're going to go through some basic stuff first and just kind of hit some of the points that we're going to go into more depth with for the future webcast. So just to jump right into it. Views around stormwater, what are the impacts to the environment? Talking about gray versus green infrastructure stormwater. Gray being the more traditional approach to stormwater, the ponds and pipes, like to say, stormwater approach, green infrastructure, I guess maybe the new thought in stormwater management, more of the integrated stormwater management approach. We're going to talk about stormwater master planning. Why are we doing stormwater master planning? Can we make, obviously nobody has endless budgets, so how do we make our investigations cost effective and efficient? I'll talk about a little.
So things are a little bit of an issue. Give me a minute and we'll be back right on.
Vary depending on, geographically, what environment you're in, whether you're in the urban, suburban, or rural environment. Talk a little bit about stormwater master plans and growth center planning, which really are parallel processes, and there's a lot of room for integration of stormwater master plans with municipal growth center planning. Get into some of the basic practices associated with stormwater master plans. When we talk about practices, we're really looking at structural practices, and those are really the things that are the practices that manage the runoff and treat runoff, swales, bioretention areas, gravel wetlands, those types of things. And then also equally as important, perhaps more important, are the non-structural practices, and that's really preservation.
We tried 2 different phones. It might actually be GoToWebinar that's having some server problems, I would guess, because we had trouble calling in. So let me test this out.
I wonder if there's a tip. Let's try this, Andres. Yeah. Can folks hear us now? Is this any better? Okay, thank you. Oh, I'm getting the exclamation points. That's great. So it sounds like GoToWebinar is having some issues. We tried 2 different phones calling in, so we're going to use the mic and speakers on the computer, and hopefully that will be better. It sounds like that is the case at this point, so we're just going to go back with that. If you continue to have sound problems, just definitely let us know. And thanks for being patient. Okay, so we got a little time to make up here. We'll dive right into the meat of this presentation, and I'm glad everybody can hear us so far. So what is stormwater runoff? So, stormwater runoff is generated when precipitation and rain and snowmelt events could flow over impervious surfaces. And the impervious surfaces are obviously a prominent element of the developed landscape. The impervious surfaces accumulate pollutants, and in addition, the precip and snowmelt running over the impervious surfaces is no longer being able to infiltrate as much into the ground. Essentially, more runoff to the stream at a quicker rate and laden with pollutants. So that is, in a nutshell, the problem that we are trying to address. When we talk about impervious surfaces, essentially the impervious surfaces are interrupting natural hydrology, the natural hydrologic cycle. In a natural environment, precipitation, there is some precipitation falls on the landscape. There is some surface runoff, but there's a lot more infiltration into the groundwater, and so the water running off the land surface that is infiltrated is taking a long time to get to the stream. The water is being cleaned, and the water is being delivered to the water resource as base flow, basically sustaining the stream during times of low flow and providing cooler water to the stream. And essentially this whole process is modified in the developed landscape such that there will be greater amounts of surface runoff and reduced amounts of infiltration. And this is just a graphic to illustrate that point. In a developed the urban hydrologic cycle, essentially getting significantly more runoff, less shallow and less deep infiltration into the ground surface, and the runoff is making it to the stream more quickly, and there's more volume in the stream during a storm event, which also impacts the geomorphic condition of the stream, often results in stream erosion. So just to illustrate that point, when we look at this graphic here, we're looking at 2 different hydrographs. And the hydrograph really is just a plot. On the x-axis, we're looking at time, and on the y-axis, we're looking at flow stormwater. And if we look at the left, the green hydrograph is what I would consider to be a natural condition hydrograph, where the flow during a storm event is metered out over a long period of time. The actual flow, the peak of that curve doesn't get too great. So when we actually get into a developed landscape and we have unmanaged stormwater, as illustrated by the blue graph, we get a high peak, much higher peak, and it's happening more quickly. So that's really the problem, because you have this disparity between the 2 hydrographs, and that higher peak is delivering stormwater with higher erosive force to the stream, resulting in erosion. And really, the goal of what we're trying to do is bring that post-development condition hydrograph in closely as possible match the existing condition hydrograph. So that's what's shown on the graph on the right. Trying to bring that back down, and that's really the ultimate goal of trying to mitigate runoff from the developed landscape. And just to discuss a little bit about what is an impervious surface, it's pretty obvious in a lot of cases. Parking lots, roads, sidewalk, pavement, all kinds of pavement, rooftops. Maybe the not so obvious are gravel roads, which are really prominent here in Vermont and other rural areas. Network of gravel roads. Some people might not consider a gravel road to be impervious, but they typically are impervious, even if you had a less impervious layer on the surface. You know, the subbase of that road is compacted, so it's behaving essentially identically to a paved surface. So a gravel road is also an impervious surface, and in a lot of ways, it's a more damaging, potentially damaging, because of the possibility of erosion from the road surface itself, releasing sediment. So just to talk about some of the effects of the impervious surface, you know, flooding is probably one of the more obvious to a lot of people. When you have developing impervious surfaces, creating more stormwater volume, more of the water being delivered to a stream at a more rapid rate, impacts conveyance structures, culverts, bridges, and essentially the water will be arriving in low places, including, you know, along the streams, and then in any depressed area with poor drainage much more quickly. So flooding is a consequence of unplanned, unmitigated impervious surface. Sediment plumes are also pretty striking feature, and often resulting from impervious surfaces. The creation of more stormwater, higher rates of stormwater results in more erosion and results in sediment being carried downstream into larger water bodies, and such as in this photo. And the pollutant wash-off, there's a couple different things. You know, first we have sediment from road sanding material, road sanding activities, nutrients, oils and greases. All these things are building up on impervious surfaces over time. And during a storm event, you know, often they're very easily washed into the stormwater conveyance system and then discharged to receiving waters, because especially in areas where there's a good connection between the impervious surface and the receiving water. There can actually also be erosion with respect to the impervious surfaces and erosion. There can be erosion right on the impervious surface, as I mentioned before, especially in a back road kind of situation. Erosion occurring right on the road surface. Also within the drainage system serving the impervious surface. If you look at the photo here in the lower right, you know, the ditching along this road, basically the water running off the road and then causing erosion within the drainage system itself. Also at the outfall of the drainage system, so basically where the point where the water leaves the upland, I would say, and enters the surface water, you often see it's a very common feature, erosional feature, where you have a concentrated discharge point to the stream. And then also in the stream itself, so in-stream erosion, which is, you know, as we've been learning more about in-stream erosion, really significant source of nutrients as well to downstream waters. So another really significant feature there. So why do we need to plan for stormwater? Well, the pollutant impacts is clearly a reason to plan. The river damage changes in hydrology, resulting in stream bank erosion, resulting in nutrients and sediment being delivered downstream, smothering aquatic habitat in the stream. Also potentially impacting private land, as well as municipal structures, drainage structures, all reasons to better prepare for stormwater. Habitat alterations, you know, very common as urban areas have developed. there's been a lot of encroachment on streams, basically urban lands being pushed right to the stream edge, removal of riparian vegetation, removal of the the shading and the erosion resistance that vegetation provides, and that coupled with the changes in the hydrology of the stream essentially creates more weakened stream banks. Those stream banks are more vulnerable to erosion, and there's thermal impacts associated with removing the habitat, and less capability for filtering runoff from impervious surfaces. As an example in the right picture, with the parking lot, if you imagine the runoff flowing overland to the stream, essentially now it's flowing over a grass strip and then down a steep eroded bank versus a well-vegetated forested area there where there could be a lot more possibility for removing some sediment and some of the volume before it gets to the stream. And then one of the more striking impacts, I would say, is the recreational impacts of not managing stormwater. It's an impact to the tourism economy, and it's an impact which is really out there in front and really gets people's attention, I would say. And just along those lines are the property value impacts. So, if there's degradation for water resources, there's a clear link between that and a reduction in property values, and especially where, for an example, people are paying for a second home on the lake, and you can't use the lake for 3 months out of the year because of the algae blooms. It really does get people's attention, and it affects property values. So just an overview on how presently stormwater has been managed for the most part up until this point. Stormwater has really been managed historically by engineered systems, and that's what we call gray infrastructure. And gray infrastructure serves to basically get the water off the site as fast as possible, and get the water underground and get the water delivered to the stream away from the developed land surface. So what we've done is created a really good connection between the impervious surfaces and the stream. So when it rains on the impervious surfaces, the water runs down the drain through a storm sewer and gets delivered to the stream quickly. So that is what we would consider kind of the gray infrastructure approach. And as I mentioned, the thing with the gray infrastructure really links impervious surfaces together. So for example, a parking lot and perhaps some roofs, which may not be adjacent to each other geographically, are linked by means of drainage conveyance, so pipes. And in turn, those impervious surfaces are linked to the water resource. So the more efficient delivery of contaminated stormwater and more stormwater being delivered to the stream is the consequence. And that process really gets us further away from this natural hydrologic regime that I was talking about previously, where you have more of a delayed and filtered pathway by which precipitation actually makes its way to the stream, and gets us more toward the urban hydrologic cycle, and in which greater runoff is more than the natural systems can handle, and also a lot of times more than what the man-made systems can handle downstream at say stream crossings, and it's oftentimes very much a problem for municipal road crews to basically just maintain infrastructure which is being constantly challenged by high stormwater flows. So how does stormwater master planning create cost-effective solutions? So nobody has an unlimited budget, and the problems are so immense in a lot of areas that there really has to be a framework for zoning in on key pollution hotspots, as I'd like to say. So areas of in watersheds where there is should be a focus for fixing first, because there's a disproportionate amount of pollution being generated in the watershed. So that's really one of the keys to stormwater master planning. How do we key in on those hotspots? Second thing, stormwater master planning proposes solutions really to implement best management practices. So the things like bioretention areas and basins and swales, where they can be most effectively managed. You really consider, land ownership and access for maintenance. And really where, and also where spatially they're needed most in the watershed. So that's also a key to stormwater master planning. And why does this work better? Stormwater master plans typically would provide the cheaper ounce of prevention, not always the often more costly pound of cure. And what that means is that, oftentimes it's easier to plan and implement good non-structural measures in the watershed, plan development accordingly, and rely kind of on good site design rather than fall back on structural measures. And, stormwater master planning can be, we're going to be talking about using stormwater master planning for basically better designing greenfield sites, so new development, better planning for new development, but also for retrofitting, coming back and fixing problems. And it's always a cheaper, easier option to basically do the right planning first. And stormwater master planning can definitely be used, and it's really critical, I think, when you have to go back and retrofit. But it's often much more expensive, much more complicated, and not as effective, I don't think, overall, versus just planning right and using good site design and as far as protecting natural features, etc. The other thing with stormwater master planning is it's certainly needed to look at the watershed scale. So having a holistic look at the watershed, because it's without looking at the whole watershed first, instead of looking at the site scale, essentially you need to have that bigger picture to understand really what the challenges are in the watershed and who the players are in the watershed, because there's oftentimes a lot of different stakeholders in the watershed. And I think an effective stormwater master planning approach really needs to understand who the stakeholders are, what the problems are, and you have to be prepared to involve public input, because there will be public input, and you're always dealing with landowners and stakeholders, other stakeholders in the watershed, because the nature of the problem is that it's scattered throughout the watershed. So there's really a need to involve public input as well. So just to touch on some of the non-structural, I would say, measures, really, when looking first at a stormwater master plan, one of the big keys, I think, is to preserve what you have already and to identify important natural features and to preserve those features. So some examples: stream buffers, lakeshore buffers, wetlands, headwater areas. These natural systems are attenuating runoff. They're filtering runoff. They're providing good base flow, cool, clean base flow to the streams. They're sustaining the water resources. And so the most effective approach really is to have a good plan early on, I think, in a master planning effort to protect those natural features. Another important consideration for protection is soils. Steering development towards soils which poorly infiltrate to begin with. So when they're paved over, the change between those two conditions is not as great. And focusing on trying to protect good sandy, productive soil for infiltration, because those are really where you can get the most benefit for reintroducing the stormwater back into the ground and returning it down to the groundwater. And a little bit further along that process, obviously there's a few steps in between as far as kind of IDing, one of the steps being IDing the water quality hotspots in the watershed, so where we want to focus our attention. But once we have focused our attention, we're really looking at creating a list of prioritized site areas for implementing best management practices. And we really have a large toolbox of best management practices which we can use now to manage runoff, gravel wetlands, bioretention. You can see the list here, pervious pavement, cisterns, infiltration trench, and then what I would refer to as a non-structural practice, just good site design kind of practices, reducing impervious surfaces, disconnecting impervious surfaces, so removing the link between the impervious surface and the stream, leaving vegetated buffer strips. All these things are components of the master plan once we identify where in the watershed we need to implement fixes. And I would say typically that these green practices, there's more variation and more options, I would say, versus more of a gray traditional approach where we're mostly relying on catch basins and storm sewers and ponds, basically to convey water to a point, detain that water, possibly get some water quality treatment, and then discharging the water. So just to get into who can create a stormwater master plan, these are the most common groups that are creating stormwater master plans today. Would include a watershed association, private developments, academic campuses, municipalities, and resorts, I would say, ski resort, something of that nature, and then also a state or federal agency. All these types of groups would have a need basically to better plan for stormwater, even for either a developed site or for in a greenfield situation where there's future development being proposed. And when we talk about different types of stormwater master plans, there's really it really depends on where what your watershed looks like. Are you in the urban environment, or are you in the rural environment? Is it a suburban? Is it a mix? I mean, potentially sometimes you'll have a mix of these different land uses within the watershed, and you may have to adapt your approach even within, if you're doing a master plan for an entire watershed. Oftentimes, we've discussed the impacts of impervious surfaces, and definitely impervious surfaces, I would say, are the main problem. However, there's a lot of other things in a watershed which may not be as obvious that are also potentially problematic for changing hydrology and also discharging pollutants to the stream. And just some examples, golf course development, for example, you have a lot of under drainage, potential fertilizer issues there, ski trails, development, on the mountain, from the ski trails also, a lot of the base area development, changing the hydrology just by kind of channeling water from one place to another. So just the means of the hydrologic modification, and also some of the land use changes associated with clearing trails, that type of thing. Logging operations, farming, all kinds of farming, lawns, all those things have the potential to discharge pollutants and also change drainage conditions such that we're concentrating runoff, increasing runoff, and potentially creating spots where there could be erosion by focusing runoff on a certain location that maybe historically did not receive runoff, or is an unstable area to begin with, that type of thing. So it's always important, I think, to remember not to look beyond the impervious surfaces sometime too. And just getting back to the preservation of the importance of preserving natural areas within a master plan. The Headwater areas I think are especially critical for protection, given the fact that headwaters are sensitive areas. They're really susceptible to modification. Whenever there's any disturbance in a headwater area, the streams are small and they're often unstable, obviously a very steep environment. So any development in the headwater areas has consequence downstream, and downstream, in a typical development pattern, is really where the concentration of the development is located. And so it's always a wise idea to protect the upland areas, the headwater areas, when thinking about master planning, just for protecting water quality and also protecting against flooding and erosion downstream. And originally I mentioned growth center planning in the context of stormwater master plans, and really the two processes are parallel, and there's a lot of opportunity within the growth center planning process to also develop stormwater master plans. And the reason being that the growth center planning goals are really protecting and enhancing designated downtown areas, town centers, village centers, neighborhood development centers, and really also looking at kind of projecting out development patterns and the 20-year build-out analysis here, and projecting out 5-year capital improvement plan for both wastewater and stormwater. Inventorying all the public spaces in the area that's being analyzed, and identifying natural resources and the potential impacts to those resources. And that's really, right along the lines of what we're looking at with stormwater master planning. So there's a lot of room, I think, to integrate stormwater master planning within that process, because many of the requirements are the same. So just to get into some of the basic outlines, and I think it's just important to understand, I don't believe that the water quality problems, all of the problems that we identify, require the same level of planning, the same type of planning. Just to give some context, in an urban environment, you typically would have a much more complex system. Even in a lot of urban environments, even to understand the drainage conveyance system, so what catch basins connect to what catch basins, and where the utilities are located. I mean, that can be a complex job in itself, and it's often, when you're in the urban environment, I think master planning can be a much more complex task, and it really requires a more complex set of tools, I think, to accomplish the goals in an urban area, because another consideration is you're often dealing with more landowners, you're dealing with more plans and more data, and the complexity gets ratcheted up. And the idea being that you have a different situation in an urban environment where you may have a combined sewer overflow issue, which is really the driver for the water quality problem in the area, versus in the rural environment where you have road erosion and you're looking at better stabilizing part of the back road drainage network. So you have some really different problems, and I think that they require different solutions. We're going to get into that a little bit, not so much in this webcast, but in future when we go through the model templates. But really, to reiterate what I was saying before, our stormwater master plans can really use a combination of structural practices, the swales, the basins, the filters, the things out there structurally that we can use to manage runoff, and then the non-structural, just good site design practices, incorporating vegetation, dispersing stormwater, preserving natural areas in the watershed, and then also the combinations, which is really the most common thing, where we have a combination of structural and then non-structural practices. I'd like to just give an overview on some examples of some structural practices. Bioretention areas are becoming a pretty prominent structural practice now. I'd say more so in the urban environment. Bioretention areas are filters that are designed basically to accept runoff and filter the runoff through soil media. In areas of good soil, they can be designed to actually infiltrate the water back to groundwater, or they can be designed in areas of poor soil basically to return the water to a catch basin after it's been filtered through an underdrain. Another increasingly popular BMP, I think, is a constructed wetland, specifically a gravel wetland, where you have a created wetland with gravel under the subsurface, and water is being treated by being pushed through that gravel layer and interacting with the plant roots for pollutant removal. Stormwater ponds are probably the most common practice out there. They've been around for a long time. They're quite popular because they're easy to use, or easy to design, I should say, or people are most familiar with them. So they're very prominent, and they probably always will have a place as a best management practice. But I think that they're maybe increasingly being resisted by fears of open water and liability associated with that, also mosquito problems, etc. And example of some of the non-structural practices. One of the more things that people might not consider to be a best management practice is really just the urban tree canopy. But current research has really shown the importance of the tree canopy for intercepting stormwater and mitigating a lot of the stormwater even before it can reach the surface. So we're finding that the tree canopy is really important for acting like a best management practice. The other type of practice is an impervious disconnection, and that's often a relatively simple practice, really just removing a connection to the sewer or the storm drain. Oftentimes a roof downspout, such as in this picture here. We're basically removing that connection. Instead, we're channeling that water onto a vegetated surface where that water can be filtered through the grass and infiltrated into the subsurface instead of being routed directly to the stream. So it's just a way to kind of disconnect, cut off some of that drainage. And then street sweeping, a really important BMP that's often primarily used in more urban areas. But the street sweeping is really key to removing those pollutants which are building up over time on the impervious surface before they can be washed away into the stream. And then we have, really a combination, structural and non-structural practice. One good example is urban trees with some amendment underneath. Silvicell, which is basically just storage underneath the subsurface, provides some additional stormwater storage. So we have the tree, as I would say the non-structural maybe, considered non-structural, and then more of the storage feature underneath. And then, water quality requirements and zoning codes, I guess, the zoning code being, the regulation which is driving good site design. And so it's kind of a hybrid, good site design, and then, structural features being built on the landscape, but also just the requirements kind of driving good site design, preservation of buffers, preservation of natural areas on the site. And then something like an urban preserve. This is a really dramatic example. But an area where you have a structural best management practice, but this thing has an ecosystem service, and it's got a community service. It could be a focal point for the community. It could also serve recreational opportunities, that kind of thing. So it's got this dual purpose of preserving the natural environment and ecosystem service, and also mitigating stormwater. Now, just to go through the basic model outline of stormwater master plans, which is included in the Vermont DEC guidance document. And really, I think that this is going to carry through for all of the master plan variations that we talk about through the webcast series. And I think with any master plan, no matter what you're doing, you really are following these main steps when you're developing a master plan. And really, just to start, you're defining, first of all, defining the problem. And this can be pretty tricky, and there may be multiple problems, and there probably are multiple problems. But I think the key is to really figure out maybe what the main problem is. What is your objective in the study? You may have a stream which is being degraded for a variety of reasons, but if the goal of the master planning is to reduce the sediment load from washing off from parking lots, you just need to establish, I guess, what your targets are initially, so you can kind of devise your strategy for moving ahead. And after defining that existing problem, typically the next step is acquiring existing data. And this can really, the amount and complexity of this data can vary pretty dramatically depending on where you are, whether you're in the urban environment or in the rural environment. The quality of the data is going to vary pretty dramatically. Often nowadays GIS data is pretty well available. It's definitely better in an urban environment. A lot of times we have access to LiDAR, which is really incredibly important, I think, for master planning. Where there is good LiDAR, you have good control for understanding water flow directions, and also doing some initial designing of best management practices. Also defining your drainage areas. Very, very nice. Also, any mapped infrastructure, so catch basins, culverts, pipes, storm sewer lines, outfalls, wastewater lines, water lines. All that infrastructure is now in some areas available in GIS format. So, gathering that data is really a challenge, but I think really important. It's also important to know if there's been any in-stream studies. So what are the conditions of the stream? Are there reaches of the stream which are more sensitive or more degraded than others? That's really good to know, because that can really help you focus your attention where you're going to be focusing your fixes. Any flow monitoring data, that may be important depending on how complex your master planning effort needs to be. you may be interested in if anybody's actually monitored stormwater flow in the streams. Road erosion inventories are getting pretty common here in Vermont, especially in the rural areas where there's been a big push to actually inventory erosion areas along the back road network. A lot of times that data will be available in a geographic data set. That's also really critical data. There's no reason to recreate the wheel. It's always good to use existing data wherever possible. And it's also a really good idea to have an indication of where existing and proposed, perhaps, stormwater permits are. So where there are sites that are actually covered under a permit, which would require a best management practice. It's good to know what those practices are and how they're being maintained, and it's just always a good source to get some more refined plan information. And a lot of times, by reviewing plans associated with a site that has a permit, you can gain information even around the surrounding areas, because sometimes there'll be plans out there which kind of cover the area even around the site. So you might learn more about the drainage network around the site, and also, on the site as well. So it's always a good idea to do a search of permitted sites. After acquiring all that existing data and digesting it, next step typically is to do a windshield type survey, where you're really just trying to get acquainted in the watershed, find your way around the road network, understand how the stream flows through the watershed, understand how the parcels are laid out, where the residential areas are, where the commercial areas are, where the ag areas are potentially. So really just getting a feel for the watershed, and then assessing the need for any new data. And depending on your objectives, you may have a need to do a pretty comprehensive mapping of new data, collecting new drainage culvert, best management practices that are out there but may not be documented. It really, again, depends on your needs and your objectives of the study, how detailed you might need to get with collecting new GIS data. Again, depending on your study, you may wish to actually monitor stream flow or water quality in the stream. For example, if your target pollutant of concern is chloride, for example, you may choose to monitor the chloride, understand how chloride concentrations might vary with stream flow, might vary with seasons. So again, it's dependent on the objectives of the study. Typically, with a smaller, kind of less intensive study, you may not really have a need to actually conduct a flow monitoring or water quality investigation on your own. It's often a really good idea to evaluate the programs which are in place within your study area, the programs through the state or the municipality related to stormwater. What are the requirements in the study area through zoning? Are there special overlay districts for stormwater? Are there special requirements for erosion control on your site? And it may be one of your objectives to evaluate that existing program and realize or understand where there may be room for improvement and room for strengthening of those existing programs to better control stormwater. And that may be one of your conclusions of your study, possibly providing recommendations for stricter zoning ordinances, different, more flexibility as far as what management practices can be installed in the watershed, the effectiveness of erosion control measures, the way that things are set up presently in the present system. So you might have some recommendations for new program development. And then finally, it's always a good idea to tie all your findings together, and a lot of times, or I think every time really, you'll have some future, you'll have some data gaps and some needs for future study. But I think it's really important to have that clearly documented in your final report, along with any new data that you've collected, that in a format that somebody else not familiar with the project can actually pick up and utilize, and pick up where you left off and not have to go back and recreate things that you've done. And I think that's really important as projects kind of get the phases of projects get passed from one group to another. It's really important to have a train that that somebody can follow and understand what's been done, what the data gaps are, and what needs to be done in the future. In addition, in the summary report, it should really end up having a priority list of projects. So you not only have a bullet list of the projects, but they're also prioritized. And there's a lot of ways to prioritize projects. There's a lot of different metrics that can be used. You know, the amount of treatment that a project provides, the community benefit of the project, the amount of flow control, whether or not the project solves an existing flooding problem. So there's a lot of creative ways, I think, to organize a priority ranking system, so you can actually have a list of projects and then a recommendation for kind of a project which should be implemented before another. And obviously cost is another big consideration, I think, depending on what budgets are. You know, some projects could be very important, but could be really, really costly. So those might fall to the bottom of the list, at least for, you know, in the short term. But also another really key thing to have in the final report is a recommendation on the sources of funding the projects. And so because there's a lot of various funding sources out there, and having that information linked. You know, it may be that certain funding source is only available to a certain type of project, and it would be good to key in on that. You know, some funding may only be available for a low-impact development project, for example, or only, as we're going to see in our other webcasts that we get into, you know, in some geographic areas where you're under certain stormwater regulations already, you may not be able to utilize some certain types of funding. Just to recap, the model outline achievement, and this is taken from the Vermont DEC Master Planning Guidance document, is really, again, defining the problem, collecting the existing data, determining what new data you may need to meet your objectives, evaluating the existing and the proposed program within the watershed, what the requirements are from the municipal and the state level, and then giving a clear summary with recommendations that can be used by others that may not be familiar with the projects that you've done. And by meeting each one of these bullet points, you'll be fulfilling what's going to be called the model template requirements, and that's really the goal of the planning document that's being put out there now. So that's the end of this first webcast here, and I'm not sure if we have time for questions or.
We do. I'm going to run a quick poll, so hopefully folks will get this. I'm just trying to determine how many people are actually on the webinar. So you can answer this question: how many people are participating in this webinar at your viewing site? That would help us quite a bit. Thank you very much. And we're going to open up these questions here. I'll leave that poll going for a little while, see if anything popped up that is of interest. Let's see. Well, we definitely got a lot of the audio questions on here. And I guess we solved that one. Took a little bit, but we did. Let's see. 2 questions here from Richard Stone. I think this was in relation to the 2 hydrographs that you had originally shown.
Right.
So what is this percent prior to development?
I think he's referring to the amount of maybe the surface runoff versus groundwater infiltration. We were showing a graphic where there was 55% runoff after development. I think he's referring to what those percentages are before development.
Yep.
And I actually don't have the number exactly. But so I'm sorry I can't answer that question specifically, but it is the trend obviously is that the groundwater infiltration is reduced considerably after development, and the amount of surface water is increased, but I don't have the percentage exactly.
Okay. And then Bob Hyams. Hey Bob, Charlotte, asking a question here. Can you talk more about road erosion inventories? Who has conducted them in the past, and where can we access them?
Yeah, so road erosion inventories is we've actually we being Watershed, our firm has been involved in these road erosion inventories as well as the state and also some nonprofits groups in the area. And really, just to give you just a quick overview, the road erosion inventory is being done as really I would say a three-step process. The first step is doing a desktop computer analysis to basically identify areas within the back road network which are susceptible to erosion by means of slope, soil conditions, proximity to water resources, and there's a few other parameters. But then taking that information on the desktop and actually going out into the field and visually looking at and finding and then assessing road erosion and going through a scoring of the road erosion area and determining how significant that road erosion area is in terms of impacts to water quality. And we have a scoring analysis where we've looked at the amount of water running through the erosion area, and then the condition of the buffer between the erosion area and the stream. So how well the erosion is being trapped by natural vegetation, or is it basically being delivered right to the stream? And so there's a scoring matrix for that, basically ranking the projects. And then the third step is really once the projects are ranked, the highest priority projects are typically brought to the municipality and for grant funding through Better Back Roads program. So there's been a lot of towns which have gone through that process and now have a list of priority sites that they're submitting grant requests for, basically implementing fixes, adding stone, adding vegetation, that type of thing. So the data, I think, can be accessed. I don't know if it's really in one clearinghouse necessarily yet.
Not yet.
Not yet, but I think we're maybe working on that right now, and I think in the future it might be more readily accessible, kind of in one clearinghouse.
Did you say the state is compiling that? You didn't quite come through that there will be. He doesn't need the town's not going to do it. They're going to provide it.
Yeah, well, there's an important point that was just clarified here, that the state is actually actively working on doing an assessment for and developing kind of a firm protocol for the entire state. So we're in the process of basically doing this inventory on more of a statewide level. So you wouldn't necessarily have to do this. This is an ongoing effort.
Right. So there was a GIS erosion analysis that was done, and that's on the Vermont A&R Atlas. So that's available. That's a layer that's available. And then the road erosion inventory pieces that Andres were talking about, that's being developed currently. And at some point, when those two projects are done, we'll do some PR and outreach on those to RPCs and municipalities about, how to access funding from Better Back Roads and whatever else. Ruth Wallace has a question. Can you talk about road stormwater practices that are unique to controlling chlorides? That's a good one.
Yeah, it's really, with chlorides, it really comes down to managing the application. Chloride really passes from the impervious surface to the stream, and it's really not picked up at all. And within the vegetation, there's really no way to actually remove the chloride. So really, the best approach for chloride is to better manage the application of the chloride.
Right, and there will be some guidelines posted on the smartwaterways.org website that the Vermont Agency of Transportation has is promoting within their agency, but also to municipalities, largely involving salt brine and the use and pre-wetting of salt prior to spreading, which can significantly decrease the amount of salt that is being used on a per mile basis.
Yeah. So that was Jim Pease. For folks that don't know, he had worked on developing the Stormwater Master Planning Guidelines, works with me in the Ecosystem Restoration Program. Yeah. All right, let's see if there's any other questions here. Abe Collins, so are there procedures with Stormwater Master Planning to assess the degree of permeability of agricultural lands and to address this as part of the Stormwater Master Plan?
Degree of permeability, not that I know of. No.
Critical source area is the critical source area, I guess, would be a type of stormwater master plan, but more focused on agricultural lands.
But is it actually going to assessing the degree of permeability of the ag lands? I'm not quite sure about that answer.
Not sure on that one, Abe. If you want us to follow up on that, just send me an email or get in touch with me. Yeah. I don't think there's any more. So any last burning questions from folks? Oh, wow, this one's a long one. Maybe it's just a comment. All right. So it looks like in Oregon, the National Marine Fisheries Service, during ESA consultation for threatened and endangered salmon, requires that we mimic natural hydrologic conditions in any new development and redevelopment. Typically, the goal standard is to mimic pre-development hydrology, which may not be the undisturbed natural conditions that existed before human settlement. From your experience, is it realistic to believe that one can match the natural hydrologic curve during the management of stormwater during urban development, emphasizing non-structural controls to a high degree and, when necessary, structural controls?
In my opinion, no. I don't think you can realistically get there. But I think you can go that direction. And I think the closer you can get, the better. But I think we'd be unrealistic to imagine that you could intensively develop an area without having some impact on the natural conditions of the stream. I just don't think. I think there's too many variables there. But I think the closer you can get to trying to mimic that natural condition, I think the better off you would be, and the more improvement that you would show at the stream.
And then Carrie Dolan, hey Carrie, has a great question. How much does it cost to develop a plan?
I would say anywhere from $2 to $50,000, $100,000 plus. I would say it would be really dependent on what your objectives are, I guess, of the plan, and where is your study area, and are you looking at master planning for maybe a facility such as a school. We've seen kind of some real small scale type master plans, which maybe the objective might not really. It might just be to initially kind of tease out kind of where your focus areas might be, not necessarily take things to designing best management practices, etc. Or it could be, a whole watershed scale, urban watershed, highly impacted urban watershed, with the need to do an intensive modeling analysis, potentially also a flow monitoring analysis to calibrate your model, and then getting into designing best management practices, which is a whole another layer of complexity, I think, and it really, I think, just depends on what the needs are.
And then I think this might be the last one. So Bob Hyams coming back in. Do all roads need to be ditched?
I would say no. I think all roads definitely don't need to be ditched. I think that one of the best management practices out there, just in the context of back roads, is a really nice vegetative shoulder, and keeping water diffused and allowing the water runoff from the road to flow through that grass strip is an excellent BMP. In some cases, there's definitely a need for ditching, especially when you have a road and you have upslope drainage above that needs to be controlled. You need to have some kind of a ditch there. But I don't think that the ditches necessarily always need to be deep and big and stone lined. I think better kind of breaking up of the drainage and some thought from a design standpoint can eliminate the need for a lot of ditching, which sometimes unnecessarily concentrates the stormwater.
Okay, great. So that was our last question. So thank you, everybody, for attending today, and thank you, Andres, and also Dana Allen from Watershed Consulting Associates for putting on the presentation. Really appreciate it. That was great. Just a reminder that the webinar was recorded, even with the technical difficulties. So I'll put that on the YouTube channel and just probably jump ahead on that to 5 minutes in. You'll get the good stuff. So you can see the link to the YouTube channel there. And then if you have any other questions, follow-up questions, or feedback, definitely send that along to me. The next webinar in the series is scheduled for Thursday, October 2nd from 2 to 3:30. It's going to focus on stormwater master planning at a small watershed scale utilizing a decentralized approach, so low impact development, green stormwater infrastructure. So sign up for that if you haven't yet. That's on our website. And yeah, thanks again, and hope everyone has a great day. Take care.